On the last video, I discussed the importance of being able to identify and graph speed and velocity. We spoke about the importance of knowing the difference between those two, speed and velocity, in which speed is a scalar quantity and velocity is a vector, in which we're concerned about the magnitude and direction. Now I want to look at how we're going to graph these things and what that means inside a physics course and how that looks. In order to talk about that, we must talk about a couple of terms that are important for us and look at a couple of things on graphs. So I'm going to do the first thing I'm going to do is that I'm going to add some shapes, and I'm going to make let's see if I can do this the right way. I am going to make not like how thick that is at all. I'm going to make a graph. Good. And on any graph situation, what you should be aware of is that you should be aware of the fact that this axis right here is known as the y-axis, and this is the x-axis. So y, we generally call it the rise, because it determines how far up you go, and the x, we'll call it run. So I'm going to just put some tabs here. In reality, you would measure these guys out, and I know I have an option to do that with this program, but just want to make this a little quicker so we can kind of know what's going on. We can get the justification of the basis of this, then it'll be pretty simple for us. That last one was too close. I'm going to space it a little bit better. All right, so I'm going to look at a couple of things that's important. So if I had a point, and let's say that point was right here, I will look at that point and I'll say this is 1 and that's 2. So on the x-axis, its point would be 2, and this is up 2 for the y-axis, so it'll be 2, 2. And that will be where that point would be. If I want to pick another point, let's say hypothetically that this point was right here. And I'll say this is over 1, 2, 3, 4, 5, 6. So I'll say this point is 6 for the x, and 1, 2, 3, 4 for the y, and we'll have that point. Now, in math, what would happen is that what you should understand is that if you have these 2 points, I can connect these 2 points. And I can make it where these 2 points are connected to one another so I can figure out a couple of things about it. So I'm going to try to do that real quick and get a shape. 1. And I'm going to go through both of these if I can. Good. And I'll get through both of those points. The other thing that I learned in math, and something that you should know from grade school, is that we learned about something called slope, in which m equals rise over run, which is y2 minus y1, and then x2 minus x1. So in this case, what I would do to get y2 minus y1, it does not matter which point. I'm going to call this point right here my 2. I'm going to call this one my 1. So y2, remember x was the first number, y are the second numbers. So y2 is 4 minus y1, which is 2. And that's going to be over x2, which is 6 minus 2. So my rise over run would be 2 over 4. If I want to reduce that, that'd be 1/2. What that means here, if I go up 1 and over 2, no matter what, I will always be on a spot that's on this line. Up 1 over 2, I still be on this line. Up 1, over 2. I'll still be on this line. So that's how we calculate slope. So slope is rise over run. These two things, the x's and the y's, those things are known as variables. So what's important about the variables is that in physics, we have two types of variables. We have what we call an independent variable, which is a variable that kind of works on its own. And that variable is always represented on the x-axis. And then we have a dependent variable. And that one's always represented on the y-axis. So when we say independent and dependent and we start looking at speed and velocity, we are aware of a couple of things. I asked the students before, let's just take speed, for instance. If I say it like, what are the things that are important when calculating speed? And most people will answer by saying, well, the time is important and the distance, because both of those two things is how you calculate speed by the equation of speed equals distance divided by time. So if I was to ask you which one of those guys are independent and which one is dependent, the answer that you'll find is that time is independent. And we know this because if I gave you a certain amount of time to determine how far you can go, that time is independent, but how far you can go depends on how much time I give you. So your time, your distance depends, okay, on what time it is. So with that said, anytime we're going to do a speed or a velocity graph, it's really a graph in which your time is on your x-axis, and then your velocity, your distance is on your y-axis. So when we figure that out, I'm going to make another graph real quick, and we'll throw this one in. To figure that out, let's go look at another graph. Good. We can look at a couple of things about a graph. So let's go take a couple of points, and I'm going to do this, and I'm going to go make a straight line. So if I had something like that, and I'm going to change the color, and I had another line, I said that line was like this. And I was trying to graph the movement of someone running, two guys running. So this right here is runner number 1, and this is runner number 2. That's their time, and this is their distance. I can ask a couple of questions. I can ask, well, based off of this, who was the fastest? Who got to a certain point, a certain distance? Let's say, hypothetically, this distance right here, and let's say the top distance is, let's go make this a pretty good race, 100 meters. And if you were to answer that question and say, well, the second runner, number 2, did, this person reached that distance in a short amount of time than this person. This person would have reached it at whatever time this is. So we figured that out, that the second person obviously was the fastest. They had the least amount of time and reached the same distance. When we look at these things, though, what's important is that if I was to ask you on this, what was the slope? Well, remember that slope equals rise over run. And in this case, the rise is distance. And the run is time. Now, we discussed this earlier, but something else equals distance over time, and the answer for that is the speed. So in this, it's important that you understand that speed equals the slope of a distance time graph. They are exactly the same thing. In fact, you calculate them the same way. So I'll take like the 2 points and I'll do the same thing that we just did inside the last calculation, and the actual number I get would actually be the speed. So let's say hypothetically, I'm just going to make these numbers up. Let's go 1, 2, 3, 4, okay, 5, 6. I'm going to go 1, 2, 3, 4, 5. So I have 2 points now. I have 1, 2, 3, 4, 5. So this right here is 5. This is 1, 2, 3, 4, 5. So this is 5, 5. This point right here is 4, 1, 2, 3, 3. If I was to ask for the slope, I would go for, if I can spell slope, if I was going for the slope, it equals rise over run, but it's the x, y2 minus y1, x2 minus x1. So y2, that's going to be 5 minus 3 over 5 minus 4. And that's going to be 2 over 1. So in that case, it equals 2. Or 2 over 1 up 2 and over 1 for each one will put me back on this line. Okay, so that's what's important about that. The deal is, I know that this variable is taken in units of distance. In this case, it's whatever the distance may be in meters. And let's say time is taken in seconds. So really, this would be 2 meters per every second. So therefore, this is 2 meters per second. So therefore, this slope represents the speed of this particular individual. I would expect that this guy right here, between two different points, have a larger number. So the slope is the speed inside of a distance or displacement graph. I want to look at just kind of analyzing some of the major aspects of like this graph. I'm going to see a couple of things. I have some issues with this graph and how I want it to look. So a couple of things are important. Since this is the case, that means that if I have a graph in which someone did this, and then they did that, and then they did this and that, and I'm going to designate each part A, B, C, and name this one D. If that's the case, I will look at a couple of things. At A, this individual has a constant slope. That means this individual is moving at A at a constant speed. Since speed is the slope. Erase that. Now B, this is one of the most missed things that happens here. At B, this individual, if you look here, whatever distance this may be, let's say hypothetically that is 2 meters, this person has not moved and time continued to go. So remember that this axis right here is time. So time continued to travel at that time, but they didn't move a distance, which means at B, this person is not moving. They have no motion. So now we covered both of these parts. Now let's go look at what happens at C. If you look at C, the slope constantly increases, and since slope is speed, that means that the person is getting faster, or C is acceleration. They're getting faster and faster and faster as the slope constantly increases. At D, this individual is kind of taper off. D is just like B, they have no motion there. Okay, the steeper the slope, what you'll learn is that the faster that person's going. So if someone did this, like this arrow right there, that person's going faster than the picture that was previously drawn. However, on that same note, if someone was doing this, this person has a less steep slope, so this person is slower than the other person. So that aspect is also important. So two things that we learned from this, and I want to highlight this last part. The real slope equation really is delta y over delta x. In most textbooks, you'll see that. Now, this may be a new thing for some of you, but this term delta always equals the final of something minus the initial. And this is why we always start off with our equation that we did earlier with, and I'm going to move this over if I can, with taking y2 minus y1, because y2 is my final, x2 is my final. So I'm going to take my final minus initial, and simply that means the difference of. And we do this, honestly, anytime we're getting the average speed or average velocity or average assessment of something. So that part is very important. Um, Later inside this class, you'll have to be able to analyze how to make graphs and do graphs and work graphs. So this part is very important. If you have any questions, please let me know. Thank you.